Hello guys, welcome to the next lecture of this YouTube channel, and today's I am going to teach you about Laplace transform. Okay, so basically there are few integral transforms in mathematical physics which is basically used to solve differential equation. Okay, so such kind of integral transforms are Laplace transform, Fourier transforms, and other transform are okay, something like that. Hilbert transform, Hankel transforms, Mellin transform, etc. Okay, where the kernels will vary, where the kernels will vary from one transform to another transform, and the constants or the limits will also be varied. Okay, so basically these type of integral transforms are used to solve ordinary and partial differential equation. Okay, so this is the basically applications of this kind of integral transform. Okay, so today I am going to teach you about Laplace transform. So what is the definition of Laplace transform and how we can define this Laplace transform? Let's see. Okay, so let f of t let f of t be a functions which is defined for t greater than 0. Okay, and the Laplace transform of f of t is given by Laplace transform f of t is equal to f of s, which is basically denoted by integration 0 to infinity e to the power minus st f of t dt. Okay, so here we can see that the domain of the functions will change from t to s, and this s is basically parameter. Okay, and the inverse Laplace transform f of s is given by, so Laplace inverse of f of s is equal to f of t. Basically this inverse is basically the reverse process of Laplace transform, so that is basically given by integration 0 to infinity e to the minus st f of s ds. Okay, now we are basically interested to find out some elementary Laplace transform of some elementary function. Okay, so first of all we are interested to give you what is the Laplace transform of 1. Okay, so basically Laplace transform of 1 is basically 1 upon s. And how can I prove it? So basically from the definition of Laplace transform we know that Laplace transform of f of t which is equal to Laplace, which is equal to f of s, which is basically given by integration 0 to infinity e to the power minus st f of t dt. Okay, so if you put if you put 1 in f of t, then what will get? So Laplace transform of 1 is equal to integration 0 to infinity e to the minus st. So what is the value of f of t? That is equal to 1 into dt. So if you integrate, this is simple integration, so this is equal to e to the minus st upon s. What is the limit? Limit is 0 to infinity. So if you put the limit, so e to the power minus infinity is 0, and minus of minus e to the power minus 0 upon s, so that is 1 by f is. Okay, so this is the simple proof. Okay, so Laplace transform of 1 is equal to 1 upon s. Okay, now coming back to the next, what is the Laplace transform of t to the power n? Okay, so Laplace transform of t to the power n is given by gamma n plus 1 upon s to the power n plus 1, or n factorial upon s to the power n plus 1. Okay, where n is integer or maybe fraction. Okay, so from the definition of Laplace transform, what do we know? So Laplace transform of f of t is equal to integration 0 to infinity e to the power minus st f of t dt. So what will be the Laplace transform of t to the power n? So that is equal to integration 0 to infinity e to the power minus st f t to the power n dt. Now if you put the st is equal to x, then s dt is equal to dx, because this is simple derivative. Okay, so if you put the value of st and t in terms of x, so what will get? Will get integration 0 to infinity e to the power minus x to the power n upon s to the power n into dx upon s. Okay, so so s is constant, so s to the power n plus 1 is out from the integration, so 1 upon s to the power n plus 1 integration 0 to infinity e to the power minus x, so x to the power n dx. So if we can write down x to the power n dx in terms of x to the power n plus 1 minus 1. So this is basically the gamma functions. What is the definition of gamma function? So gamma n is given by e to the power 0 to integration 0 to infinity e to the power minus x to the power n minus 1 dx. Okay, So what is the so from the definition of gamma function, so this term is gamma n plus 1 and the denominator is s to the power n plus 1. So Laplace transform of t to the power n is given by gamma n plus 1 upon s to the power n plus 1. Okay, so this is the proof, and we all know that gamma n plus 1 is equal to n factorial. So Laplace transform t to the power n is n factorial upon s to the power n plus 1. Okay, so now coming back to the next transform, what is the Laplace transform of e to the power 80? So Laplace transform e to the power 80 is 1 upon s minus a, where s is greater than a. Okay, so from definition of Laplace transform we can tell that Laplace transform of e to the power 80 is equal to 0 to infinity e to the power minus st e to the power 80 dt. So 0 to infinity integration 0 to infinity e to the power minus s minus bracket of s minus at dt. So if you integrate, this is simple integration, so if you put the limits, then you will get 1 upon s minus a. Okay, so basically these are the three Laplace transform important functions. So thank you.